Hello everyone, here in this video, we would like to talk about the beat phenomena, right? Before going to the beat phenomena, let me have a quick look at the concept of resonance phenomena so that I can tell you how does that resonance is different from that of a beat phenomena so that we can cover both of them. So what does resonance says is when two waves of same frequency traveling in the same direction. So this is wave 1, this is wave 2. They are traveling in the same direction. Two waves are also the same. That means what? Whenever there is a crust in the first wave, there is a crust in the second wave too. Similarly, when there is a trough in the first wave, there is a trough in the second wave too. Similarly, yeah. This is a resonance phenomenon when two waves of same frequency, same magnitude, same phase traveling in the same direction are combined together, the resultant intensity becomes large. So resultant intensity becomes A1, amplitude becomes A1 plus A2. So it becomes a big sound, a booming sound. That's what we said, like resonance air column apparatus or uh, velocity of sound experimental apparatus and all that. So the resultant intensity becomes large, becomes a big wave, and you will be able to experience a booming sound like this. This will be keep on happening, right? It's a phenomena of resonance. This will be happening together. They go together hand in hand always, so that the resultant intensity becomes maximum. So what is resonance? When two waves of same frequency traveling in the same direction are combined together, the resultant effective intensity is because of both of them together traveling in the same phase. So they're always on high. There is nothing to worry about. Now let's talk about the other phenomena that we are talking in this today's class, that is beat phenomena. Well, beat is slightly different from that of resonance. How it is different? Let me try to explain. As I told you, in the first case of resonance, the two waves are of same frequency. But in the case of beat phenomena, the waves are not exactly the same frequencies, but there are slightly different frequencies. Slightly different frequencies. That is frequency 1. So this is frequency 2. They are slightly different. Let me tell you what do you mean by how they are slightly different mean. So this is the crest of the first wave, rough of the second wave, first wave, crest, rough. That will be keep happening, right? Slightly different. That's N1. How is this N2 is? They don't have exactly same frequencies, but they're not too far. They're just quite close to each other, slightly different from each other. So what you can see here is the second wave also here starts like a crust, but slightly overshoots the first crust like this. See here, this crust and this crust are not different here. Trough started, but here it's still continuation of the crust itself. Now, as they move further, the difference will be keep on increasing. Slowly, it will be keep on increasing. And if you notice carefully here at this place, when there is a trough in the first wave, there is a crust in the second wave. So they are exactly opposite to each other here, right? So they have started with a zero phase difference, and here by the time they comes here, they got a maximum phase difference of 180 degree. They are all completely out of phase. Now what happens further is they will again slowly starts falling back into the phase. They will slowly fall back into the phase. So they are initially out of in phase. Somewhere they becomes out of phase, and again they will come back into the phase itself. So how will be the resultant because of all this? Let's try to understand. So I want you to draw the effective resultant wave of these two, that is the beat wave. So if you notice carefully, It starts like a resonance phenomena itself, that the resultant is maximum. But it's not continuously maximum like a resonance phenomena because they are not continuously in phase. Here in the first case, both the waves are continuously in phase, but here slowly they are going out of the phase. So resultant also becomes slowly out of phase. So what happens? At the beginning, as both of them are in the same phase, the resultant intensity of the wave is maximum. But when it comes to this point, when they are in opposite phase, resultant intensity becomes minimum. So from maximum to minimum in the journey, it is a gradual decrease. It will be slowly decreasing. My graph is little not that great and it may not present exactly what is happening, but I want you to understand the spirit of that. Its amplitude will be keep on decreasing and finally it becomes minimum. So here they become minimum. From where they have started is maximum. After this, they will again start coming into the phase. Already opposite phase, the worst thing is happened. They slowly starts coming into the phase again. That means amplitude will be keep on again increasing. Will be increasing. Somewhere again the resultant amplitude becomes maximum. When it again comes back to the phase. The back to the phase. Here they are out of phase. Here they are, both of them are in phase. This will be keep on happening. And this phenomena is called as a beat phenomena. This way of getting a maximum intensity in the beat phenomena is called waxing. Getting this minimum intensity is called waning. Again, there is a waxing. And I want you to understand that one waxing, that is one maximum amplitude, plus its immediate waning next to that is called one beat. So one beat means if I have to show where is that one beat is, this is starting with waxing and waning. This is over. This is one beat, right? So this is over. One waxing and one waning is one beat itself, right? Further, maximum to minimum is one beat, right? Number of the beats happens per second is called beat frequency. We can derive an expression for the beat frequency. We'll do it in the next video as difference between these two frequencies. That we will do a mathematical derivation in another video. This video is intended to only understand the theoretical aspect of how does the beats happens, right? So this is how the beats progresses. So beat phenomena is when two waves of slightly different frequencies traveling in the same direction are superimposed together. There is a formation of waxing and waning in continuation, and that phenomena is called as a beat phenomena. That's it. Thanks for watching.